When you are done putting those 2 dots on the graph, please put the next 2 dots on the graph. Those 2 dots are going at... Actually, we're going to stop right there for now. Everybody's got those dots on the graph? Where is your first dot? Take me there. Left. How far? -5. 1, 2, 3, 4, 5. Does everybody agree that's where their first dot is? Yay! Why is it there?
Because he said 2 dots.
Huh?
He said 2 dots. And also you didn't say what y was.
I didn't give a y coordinate. So the only thing you know here is x is -5, which means if I draw a line through there, what does that give me? If a line passes through that dot now becomes what? -5, 0, which is what? What do we call it when the line crosses an axis? An x-intercept. Lovely. Everybody's got that first one, yeah? Now put a second one at x equals 0 and y equals... Oh, wait, sorry. We got to put our y at 4 first. Where's our y at 4? Up 4. 1, 2, 3, 4. Right? What have I got as soon as I connect those? What have I made? A slope, right? I have also made now an x-intercept that Ash has already talked about and a y-intercept. What is that slope? The red slope. What is slope? Four over -5? 4 over 5. Right? Because I went up 4 and over 5. Is everybody good? Yeah? Okay. Now, put a dot at x equals 0. And put a dot at wait a minute, I gotta think about this. At 4, 5. There's x equals 0. And where is 4, 5?
Is it 4 on the x-axis?
Indeed. 1, 2, 3, 4. And then what?
5 is over here.
So, where do I go from here? 1, 2, 3, 4, 5. Agreed?
Yes.
Oh, I went up 1 too many. 1, 2, 3, 4. 1, 2, 3, 4, 5. Now, look at those 2 lines when I'm allowed to make it. When I'm allowed to make it. When I'm allowed to, there we go. And what do you know about the next red dot and the next blue dot? Where will the next red dot be? Up 4, 1, 2, 3, 4, and over 1, 2, 3, 4, 5. Correct? Everyone agree? And that line would continue. How long would that pattern go for? Infinite, right? Where would the next blue dot be? Oh, we forgot to do the slope for the blue dot, the blue line. What was it? 5 over 4, right? Okay. So how would I find that? Up 5, 1, 2, 3, 4, 5, and over 1, 2, 3, 4. And what do you see is about to happen? They're going to cross over, right? What in all of these measurements is the thing that makes it certain that they are going to cross over? The slope. Because the slopes are different, they have to cross over. Correct? Everybody understand? Now, I have told you I wanted you to draw parallel lines. What do you know about the word parallel? No, that's vertical. That's horizontal.
It's straight.
All lines are straight.
They go at opposite directions.
They're side by side because you need two lines. And what do you know about parallel lines? They're never going to touch. Well, we just drew two lines with two different slopes, and what did they do? Touch. What's going to happen if they're parallel? They won't touch. So what would that mean would happen with their slopes? They would be the same. So if I put a third line on here at y equals -4 and x equals 5, 1, 2, 3, 4, 5, and down 1, 2, 3, 4. There's my green line, which is going to show up in a second. What is guaranteed to happen with the green and the blue line somewhere way down here? They'll touch. What is guaranteed to happen with the green and the red line? They will never touch. Because they're not touching now, and the next point for both of them is up 5 over 4, right? Up 4 over 5. Up 4 over 5. Does everybody understand? So, what does that tell us? If line 1 is parallel, that means parallel, to line 2, then what does that mean about the slope of line 1 and the slope of line 2? That they are equal. Is everybody good? If the slopes are different, they're going to cross. If the slopes are the same, they're never going to cross. Everybody good? Now, obviously that's visible on a graph, but it works both ways. If you find two slopes with algebra and you find them to be the same, will those two lines ever cross? No. Everybody good? Great. That's the easy one. Now, let's talk about perpendicular. First, I want you to draw not just a point. I want you to draw the line x equals -5. That's a very different thing than I just asked you to do, and it requires you to do some thinking. How do you draw a line when you are only given one coordinate? Go. If you don't remember how, you don't remember grade 9, talk to your neighbor. Serena, of course you can. When you're done drawing that line, draw the line y equals -5. I'll wait a moment for you to try to work this out, see if you can remember how to do it, and then I will ask. Does everybody have it? Or have a guess, at least? Great. How do I draw the line x equals -5? Where must I go? To -5 on the x-axis. 1, 2, 3, 4, 5. Great. How do I draw the line? It is this line because x always has to be -5. Everybody agree? Everybody remember that? Everybody understand? Great. How do I draw y equals -5? I go to -5 down. 1, 2, 3, 4, 5. And that is always going to be the case. What do you know about this angle? It's 90 degrees, which means this is perpendicular. Everybody with me? Okay. Now, what if I wanted you to tell me the rise and the run of the red line? What would you tell me is the red line's rise? How far up and down does that line go? Infinite. So the slope of this line is infinity rise over what run? How far side to side does the red line go? 0. Which makes this which slope? The death slope or the boring slope? Death slope. This is undefined. What is the blue rise? Over what's its run? Infinity, which makes that the 0 slope. Now, we've already talked about why it's undefined and why it's 0. I want to focus on this part of it now. What do you notice about those values? Pardon me? They both have infinity and 0. One of them has infinity in the numerator and 0 in the denominator. The other one has 0 in the numerator and infinity in the denominator. What do you call it when we do that to a fraction? It is a reciprocal, right? So, if something happens once in math class, what are we usually able to say? It happens every time. So when these two lines meet at 90 degrees, their slopes are reciprocals, correct? All right. Now use your brain for a moment. I'm not going to give you any coordinates. I'm just going to draw something, okay? Everybody ready? All right. Oh, I don't want to use blue and red because I've already used blue and red. Sorry. Now, let's pretend you can't count that. Like, it's too blurry up there. You can't tell me the slope. And I haven't given you the coordinates, so you can't tell me the actual slope there, can you? But you can tell me something about that slope. What can you tell me? Yeah, which is it, Ash? It is positive. Everyone agree? It's positive because I went up, which is positive, and right, which is positive. Everyone cool? Now, if I drew a 90-degree line to that, which I will draw in, what have I used? Blue, red, green, in gray. If I drew a line through here, come on. It really ruins my sense of drama. Oh, there we go. Erase that first step. If I drew that line through there, and I told you that that was 90 degrees, what can you tell me about the gray line? It's a negative slope, but it's 90 degrees. What do you know about negatives, about slopes that meet at 90 degrees? They're reciprocals. So you can plainly tell me, you know that the gray line is going to be a reciprocal slope, and from looking at it, you know that it must have a negative slope, correct? So what does that tell us about this situation? If line 1 is perpendicular, which is what this symbol means, to line 2, what do I know about the slope of line 1 compared to the slope of line 2? What will happen to the slope of line 2? It will reciprocate, and what if the first one was negative? There you go. It will reciprocate and change signs. So if this is slope line 1, which would be m of line 1 over 1, wouldn't it? m of line 1 over 1, wouldn't it? What will happen here? 1 over the same slope, and what would be out in front? A negative sign. Does everybody understand? And you can see that just from this. You don't have to do any slope work. You can see that if we start with the green one and we want 90 degrees, it's got to be negative. And we already know from the up and down thing that it's also got to reciprocate. Is everybody good? Great. So what does that tell us? Parallel lines have what? The same slope. Right? And perpendicular lines have opposite reciprocal. Agreed? Everyone agree? Okay. So, if you get that, then you should understand this. If I have line 1, what are some ways I can find rise over run? What are some ways I can find slope? Rise over run. What's another way I can find slope? Algebraically, which is what? Kieran? Yep. y2 minus y1 over x2 minus x1. Correct? Now, if that is parallel to line 2, what will happen with this rise and run and this y2 minus y1 and x2 minus x1? They would move over here and they'd be exactly the same. Is everybody with me? Okay. What if I have line 1 and it's rise over run, and it's also y2 minus y1 over x2 minus x1, and then I tell you it's perpendicular to line 2? What would happen to this rise, this number over here? Where would that go? Rise would be down there. What would be up here? Run, and it would be negative. And what would happen to these? It would also flip. x2 minus x1 over y2 minus y1, and it would be negative. Is everybody with me? Everyone is good? All right, let your brains relax for a second and just fill in the bottom of this sheet. There's 6 numbers there that you need to write. See if you can write them. Actually, I lie. There's 5 numbers and a word.
Instead of 100% on the calculus test. I made a stupid mistake that I realized as I walked out of the classroom. Because it was supposed to be maximizing the area of a farm if there's 4 pens, and one side is against the barn wall. So my thought process at the time was like, well, the height's going to be really, since the barn doesn't say how big it is, it can be as long as I want. So I was like,
you want to maximize the area?
Yeah.
But wouldn't the area be on the ground?
Yeah, I'll get to it.
Oh, okay.
So, against the wall is where the fence is, so it doesn't have that. So it's my thought process.
While Bryce is telling the story, I'm writing the 7 answers. Check. Keep talking.
My thought process was, if we make the part against the wall as long as possible, we'll have more fence for the rest of it to make it bigger. But while that makes sense when you say it out loud, the obvious answer was to just make it a big square. So I was like, I walked out, I was like, I probably should have realized that, and I really should have realized it, considering when I got the answer right under it, I wrote, shouldn't this just be a square? And for some reason, I didn't go back and fix it. Taking a hit.
Everybody good? Is everybody able to do this? Is everyone able to do this? Yeah? Yeah? Okay. Turn the page over. This question number 1 is asking me one of 3 things. It is asking me, is AB parallel to ST? Is AB perpendicular to ST? Or if AB is nothing to ST? Right? What is the measurement we can make, or I shouldn't have said measurement, what is the value that we can find that will allow us to answer this question? Slope. If the first one is true, the M of AB will what to the M of ST? If it's parallel, what will they be? Equal. If they are perpendicular, then what will happen to the M of AB? What will it equal? The reciprocal and negative, right? So it would be, we're just a little bit behind, 1 over the M of AB and negative. Agreed? And if they are neither, then the M of AB will have nothing to do with the M of AB. ST. Agreed? So, what is my job here? Find the slope of what? ST and AB. How do I find slope when I don't have a graph? Algebra. y2 minus y1 over x2 minus x1. How many times am I going to need to do this? Twice. Once for AB and once for ST. What values do I use for AB? Well, we know it's y2 minus y1 over x2 minus x1. So what values must I use for A and B? What goes where? Who makes that decision? You do. So decide. Where is there a y value that has to do with A or B? If you don't want to say it out loud, just go ahead and work it through. I personally always like, I don't want to say that. I don't want to poison you. I'm going to make this one x1, y1, x2, y2. So it is negative 1 minus 1 over 5 minus 1. Everyone agree? Maybe you didn't make the same x and y choices as I did, but when you do the math, you're going to find the same thing, aren't you? Negative 1 minus 1 is negative 2. 5 minus 1 is 4. So my slope of AB is negative 1/2. Everybody good? Every single person has negative 1/2, right? Right? Choose a color.
Purple.
Yellow.
What is the slope of ST? How do I find slope? Doesn't change. y2 minus y1 over x2 minus x1. Now I go to the other one. I'm going to change it around. I'm going to make the first ones x2 and y2, and the second ones x1 and y1. So I'm going to have negative 1 minus 5 over negative 4 minus what? What's my x1? Negative 1. What's negative 1 minus 5? Negative 6. What's negative 4 minus minus 1? Negative 3. Two negatives make what? A positive, and 6 divided by 3 is 2. Are those opposite reciprocals? Yeah, because that's really 2 over 1, isn't it? So which of these three is true? Are they parallel? No. Are they perpendicular?
Yeah.
Yes. Is everybody good? Everybody good? Great. Let's go to the next question. I have 3 vertices of a triangle. What is a vertice? It's actually singular as a vertex. What is a vertex? What do all triangles have 3 of? They have, yes, a vertex is where 2 lines meet. So the vertices must be the corners, yeah? If it's a right angle triangle, then what must 2 lines do? They must be perpendicular, which means to do this question, we must check 6 slopes, correct? So we have to check the slopes at AB, the slopes at BC, the slopes at AC. It's a big pain, right? Can any of you think of a way to lessen our workload? Pardon me? No, what'd you say? But what if you were right?
I don't think that was very good.
But what if you were?
It's fine.
You want to tell Bryce?
No, I never said anything.
But you said something. That's hurtful.
Okay.
Can I lessen my workload? I give you a hint. Seamus already said something important. What did he say? He only said one thing. What did he say? You said it. What'd you say? 2 lines must meet at 90 degrees, yes? So there must be a way where we can check only 2 lines. How do we know which 2 lines to check? It's the ones with the 90 degrees, right? But how do you know which ones have 90 degrees? By looking at it. Looking at what? Those are just numbers. No, you will be finding slope, but you don't want to find all the slopes. You're right. We need to look at the corners. But those aren't corners. Those are just numbers. Graph it. Do I have to graph it perfectly? Nope. I just have to graph it in a nice sketch. How would I do that? Well, the first thing I would do is I would make myself coordinates. And then I would put them on there. Where would A go? Everybody happy with that being A? Everybody happy with that? Okay. Where would B go? Everybody happy with B? Where would C go? Where is the only possible 90 degrees now? C. So do we need to even care about the slope of AB? Does that even matter to us? Nope. We're only going to care about these 2. So I need to check if the slope of AC is perpendicular to the slope of BC. How do I do it? I'll give you a hint. Look at number 1, because that's how math works. How do I do the slope of AC? What is AC?
4,
Minus
1,
over.
3, minus 2.
What's 4 minus 1? What's 3 minus minus 3?
6.
What's 3/6 really?
1/2.
1/2. Everybody happy? Everyone agree with Ash's math? She makes a wonderful spokesperson. Do we agree with her? I'm happy with that. What's the slope of BC? What is it? Ash, you should probably go again.
-2 minus 1.
Minus. Oh! BC. BC.
Oh, wrong one. -2. Wait.
You can still use -2 there.
No, I don't do the 4
Okay.
minus -2
Okay.
over 3 minus 6.
What's 4 minus minus 2? 6. What's 3 minus 6? What's 6 divided by -3? -2. Are they perpendicular? So is that a right triangle? Yes. In real life, will you ever be forced to describe a right triangle that way? Of course not. Will you ever be forced to solve a puzzle using knowledge from a various other pieces of your brain? This is where you say yes, and I prove my whole argument from the beginning of the day. Because I railroaded you into it, because that's what I do. I know, right? It's like a full circle. Which has no perpendicular parts. All right. Turn the page over. What do you see? You see a bunch of coordinates, yes? Those coordinates are all what? They're all points on a graph, which means they are all graphable because they are all x's and y's, correct? Once you know a bunch of x's and y's, what is something you can do with them? You can graph them, and you can algebra them to find what? Slope. I care about slope because I'm asking about slope today. If they are parallel, what do I know about the slope of AB, and the slope of CD? They would be the same. So AB's y2 minus y1 over x2 minus x1 would have to equal CD's, wouldn't it? They would have to equal, wouldn't they? Can I fill in all of those numbers right now? No, there's one spot that's unknown, isn't there? I don't know one of the y's in CD, correct? So let's fill it in. You fill it in however you want. Have I filled it all in? Is every value that I know written down right now in one of the spots? Okay, what should I do now? Sure, first thing I should do is simplify. What's 10 minus 5? What's 7 minus 3? 4. A minus 2. What's 1 minus 0? 1. What do you do every single time in math, ever, when you have fraction equals fraction? Cross. What's 5 times 1? 5. What's 4 times A? 4. Minus. What's 4 times 2? 8. How do you solve that? How do I get rid of the 8, Ash? I add 8 to both sides. What's 5 plus 8? 13 equals 4a. What's my last step? Divide by 4. So 13 over 4 equals a. Does that bother you? Why? It's a fraction. They make you guys run crying to the woods. Fortunately, your parents chased you with grizzly bears when you were kids and you learned to run. Why does that bother you if it's a fraction? Could you not find the y value of 13/4? Isn't that just 3 1/4? Couldn't you find that on a graph? Where on the y-axis would 13/4 be? Up, 1, 2, 3, 4. Would I go all the way to 4? Would I go past 3? How far past 3? A quarter of the way past 3. There it is right there. Could you find it on a graph? So should it bother you that it's a fraction? No, because it's just a value on the graph. Is everybody good? Okay. You guys do perpendicular. Yuck. Well, if it's perpendicular, we know that AB, what will happen to the slope of AB? It'll flip. So it won't be 5/4. What will it be? The m of AB would just 4/5? Negative 4/5. The m of AB will have to be correct? So AB is changed, negative 4/5. What about CD? Do we change it? Or is it still y2 and y1, x2, x1? There's two ways I can do this. If I flip this side, do I flip the y2s? No, because I'm still looking for a slope, right? Agreed? Everyone cool? What if I did it this way? What if I left this as 5/4? Then what would I have to do over here? Flip this side, so I could also do this. And all that would have to be what? Negative. Will both ways work? Let's check. Let's do the first one in dark blue. What goes where? My computer's frozen, so you guys fill it up. What goes in for y2 and y1? My computer's still a piece of garbage. Hey, rumor has it they're taking it back and re-imaging the computers. Maybe it'll work next time. What goes in? What goes in here? This is the C and D side. I've already got AB. What goes here? A minus 2 over 1 again, correct? Everyone agree? What do I do every single time I have fraction equals fraction? Great. What's negative 4 times 1? Negative 4. What's 5 times A? Minus, what's 5 times 2? 10. How do I solve that? Add 10 to both sides. What's negative 4 plus 10? 6 equals 5A. What's my last step? So what does A equal? Does that bother you? No, it shouldn't, because we can find 6/5, can't we? It's 1 1/5, which is 1.2, which is a little bit past 1. Everyone agree? What if I want to work the other way? I didn't change AB, so if I didn't change AB, I got to flip CD, don't I? Did I flip CD? Did I flip CD? Did I make it negative? So it should work, shouldn't it? Let's check. 5/4 equals negative. What are my x's? Well, we know it's 1 because we've already done it, correct? And we know this is A minus 2, correct? Everyone agree? Let's get rid of that negative. 5/4 equals negative 1 over A minus 2. Are we cool? Do I need to keep going? 4 and negative 4 and 1, 4 and negative 1. 5 in there. Everyone see how it still works? Do you see how you have a choice? It depends on what you need to do. Who decides the way you go about doing this? Me or you? You. That's it. Now listen to me. You're in this class for another half an hour. Yeah? I have given you page 190. That's an assignment. It is due for marks on Thursday. Right? You also have page 194. That's practice for parallel and perpendicular. That is due Thursday. This one's for marks. This one might be checked. You also have a Unit 5 test. That is Wednesday. That's tomorrow. And you are going to have a slope quiz.
Today?
No. When is that going to be? Thursday. There are 4 things you could be doing right now, 2 of which is actual work, 2 of which are preparing for upcoming actual work. Use your time and use it wisely. Since you use your time poorly when you are not in school, what should you do right now? Which of those 4 would be good stuff to do right now when you have Bryce and me here? And which 2 of those require you to ask for help? Whatever you're stuck on, right? That's the whole point of that trick question I just asked, Ethan. Which 2 require you to ask of help? It's your decision, right? Go. I'm going to stop the recording, upload the recordings, and take attendance, and then I will